Hi there. In this video, I'm going to give you a quick overview of how to go about modeling a business problem. So far, we have seen in the last few videos that we can simulate using a computer a specific business problem. That'll help us to learn very quickly before those problems become into reality. So what is modeling and why do we do it? What's the purpose? The purpose of modeling is to learn quickly. Modeling is an iterative process. You come up with an initial hypothesis on what causes what, and you continuously learn and improve your hypothesis. You test your hypothesis through various data points, through the history of data that you have, and you revise your mental model both in your model and also in your mind. So it can help influence policies. So that's the purpose of modeling. In the virtual world on the computer, everything is very predictable. You put in an input, you get an output. Every time you put in an input, you get an output. But in real life, there's a lot of non-linearity. If you deal with an office situation, you know that there is politics, there's time pressure, there's deadlines, there's interpersonal conflicts, there's emotions at play, there's ambiguity of problems, and so much more. So there is no predictability that this person will always behave this way every single day. It's a real life problem. So you have to realize that there is a gap between the virtual world and then the real world. But the virtual world can help us learn, and the real world can also help us learn and make the virtual world better, and vice versa. And as managers, as leaders, we have a huge role to play in organizational design, what kind of people we hire, what kind of policies we foster, how do we help decision making process, how do we create an organization structure so that ordinary people in the team can become extraordinary and not senior managers. Typically what I've seen, they get into this trap of decision making instead of empowering, and what happens is they are often the bottleneck. That just doesn't work. So the organization depends hugely on managers' effectiveness. So if a manager knows the right set of tools of modeling, then the organization is better off. So what is step one? Step one is to find a real problem before you start modeling. Do not model an entire system, do not model a company or an economy. Model a specific problem. So you have to find out what specific problem you're trying to solve. And you should only use modeling for the most important problem, not for every little thing. The most important step after you have found out your problem that you're trying to solve is to find out who your real client is. As a modeler or as someone who is using systems principles in company, not necessarily everyone will appreciate you. Not necessarily they will all understand your skill sets. But there'll be certain people who would be your clients, who would appreciate your depth of understanding of systems thinking, and they would want you to help influence policies. But the person who invites you into the company for this purpose may not be your real client. It may be someone else. So you have to, as a modeler or as a systems thinker, find out who are the real people who will be making decisions. Is it this person in blue, or is it this person with a black suitcase? Finding out your client is the most important thing. And clients are the people you must influence for your work to have an impact. This could be real line, first line managers. This could be the engineering tech leads. It could be the VP of engineering or product or design. Finding out, given a problem, who are the right set of people who you need to influence for your work to have an impact. So that's the definition of a client. You continue finding the right client after you've continued to pursue the concrete specific problem. So this is the most important step. Find out your real client. And remember, not a lot of clients are really interested in learning. They just want to use modeling. They want to use modelers to just support their own conclusions, which may not be based in data. As a modeler, it's your ethical duty, as a systems thinker, it's your ethical duty to not oblige if you think that it's unethical in certain assumptions for your model. So remember, your client may not be the person who has invited you to the company. It would be someone potentially Most of the time it'll be someone else. So find out your client. That's step 2. Step 3 is to build a model. This is the most exciting step. In this, the first step is to articulate the problem. Define the problem. Remember, specific problem, not a wide, big problem. Define your variables. Find out like what are the systems at play that actually define and shape the problem, and have a large time horizon. If you look at it in a myopic viewpoint, you will not see issues that are being formed. So problem articulation or boundary selection is the most important step. Second step is to form a dynamic hypothesis as to what do you think based on current data or current theories, what are the theories that explain the problem. Once those theories are put in place, use the right tools. There are many tools that I'll give you a quick overview in the later video to build this dynamic hypothesis. And you have to find out what are the boundary conditions. There will be things that you would want to completely ignore. There'll be endogenous functions, there'll be exogenous functions and excluded functions. You have to find out like where is your boundary and what is the hypothesis that you're trying to solve for. The third step is to actually formulate the simulation model. So you have to define parameters, decision rules, and then you have to test it with robustness with various boundary conditions and sensitivity towards extreme values. And then based on this testing and data, you will find out that there may be certain policies that may need to change. Remember in the previous video, we saw that General Motors decided not to go towards a lower subscription 2 years leasing because that had a huge impact towards their overall profitability. Similarly, for a given problem, if your hypothesis and problem formulation and testing passes, and if a policy needs to be changed, this is the perfect learning. So you change policies and you iterate and improve. And once you have a policy design decision or a policy recommendation, you would want to test what happens if this hypothesis of this new policy is true. Is it sensitive to changes? Does it interact with other policies? And you'd want to constantly monitor and evaluate so that your model actually becomes better and better. So this is an iterative cycle of the final step, which is to build a model. So now let's look at this. There are in this virtual world that we discussed problem articulation, dynamic hypothesis, formulation, testing, and policy formation. At every step, the real world, which is outside this circle, influences the virtual world, and the virtual world influences the real world. So let's say you come up with a policy decision and you try out a new policy in the real world, and then you find out that, hey, this actually solves the problem. So then you have a feedback that the model's working. But if it doesn't work, you're going to change the initial parameters to make sure that actually it works. So the model ideally should predict some parts of the future. It cannot be the future teller, but it will have some way to predict if it's catching the right variables. Similarly, when the formulation happens, our mental models also change. Our strategy, design decisions, everything changes based on outputs of this model. So the real world and the virtual world talk to each other. The virtual world policies change, recommendations change the real world policies and rules and data points change the virtual world. So this together actually makes this work in harmony. And as I said, time horizon is very important. If you look at just 1995 or 2 years of data for oil import, you'd probably say, hey, there's no difference between net imports and exports. But if you have a large enough time horizon like 1950 to 2015, you'd quickly realize that the production actually started slowing down since 1970s. And then imports went up, right? So there's a trend that you can see if your time horizon is large. Changing the time horizon completely changes the assessment of the problem and also the evaluation of the policy decision. So have a large enough time horizon. A general rule of thumb is if in your feedback system, if it takes X number of days for a feedback to come through in real world, then you multiply that by 2 and multiply that by 10. So multiply by 20. So that's the longest loop to get feedback. You want to multiply that by 20. That's the time horizon you should be looking at. In short, a large time horizon is important to have an unbiased view. So not too short, not too long. These are the tools that you can use that we will get into the later chapters that will help us to build the models. So remember, formulation, problem formulation is where we define the parameters, decision rules, and everything. There are many tools for doing this. We can use subsystem diagrams, which model the system. In this case, this data system, there's a utility that uses data, the user interface that actually uses utility to use the data. So this is a system that you can have as a subsystem. You can model this part as its own and vice versa. So you can use a subsystem diagram. You can use a causal loop diagram. In this case, we are seeing the impact of work getting done by students based on professors' fatigue, professors' morale, students' fatigue. There are various parts at play that you can see. There's a positive reinforcing loop, and there's a vicious cycle here as well. So causal loop diagrams also help to understand the system. Stock and flow diagrams. There's an input, there's a flow, and there's an output. And there are various variables that determine the input to be completed to the output. In this case, there's a backlog of open tasks as a completion rate. It's impacted by productivity and overtime done by employees. And based on the completion rate, the tickets get closed. But there's also sometimes scheduling pressure. There's also productivity impact, deadlines, and a whole host of things. So you can model as a stock and flow as well. So that's the overview of the third chapter, which is all about the modeling process overview. Highly recommend this book. Thank you. Bye.